Hello, algebra students. Mr. Lawrence here, and we're doing a little hodgepodge. Just a quick review of some things we've talked about this year. Maybe not taught whole lessons on, but things that you need to know, and maybe you got some gaps in your learning from last year. Maybe not through any fault of your own, just this adaptation to the Common Core. Anyway, we need to know these things to be successful, and we need to know them very well. So first is the Pythagorean theorem. Remember, it says that a squared plus b squared equals c squared. And the most important part of this theorem is C. Remember that C is the hypotenuse. Hypotenuse. Say it, it's fun. Hypotenuse. Okay, it is a Greek word. Anyway, let's come down here. Now remember, I suggest that whenever you use the Pythagorean theorem, you find C first. And you find C by going to the right angle and drawing a ray to the side opposite the right angle. And I would recommend filling that in first. So in this problem here, where the height is 16 inches and the base is 18 inches, C is x inches. And so I'm going to put x squared. Now, the other parts don't matter. A and B can be in either order because of the commutative property of addition. Right? You've heard me talk about the commutative property. Now, to solve for this, I'm going to square 16, which I believe is 256. I'm going to square 18, which I think is 324, and that'll equal x times x, which is x squared. X times x is x squared. All right, now I'm going to add together these two, and I'd rather do things vertically. So here we go. I'm going to get 10. I'm going to carry the 1 7. That's 8. I'm going to 580. Now, to find out the length of x, I'm going to take the square root of each side. Okay, and I'm only worried about the positive square root. I don't happen to know the positive square root of 580. Oh, by the way, I'm using a calculator that Alexa Gatos left by mistake last year. If you guys know Alexa, let her know I have her calculator. I would love to give it back to her. So I'm going to take the square root of 580, and you do understand 580 is not a perfect square. It's an irrational number, right? You've heard me mention that before. It's going to be a decimal that goes on forever without repeating. So I'm going to give an approximation. I'm going to round it to the nearest hundredth. You can go ahead and do this yourself to see if you agree with me. And I'm going to get 24 and 0 eighths, 0 hundredths, 24 and 8 100th inches, 800th inches. There we go. That is a rounded answer. There is no number times itself that equals 580, but this is a pretty close approximation to it. Square root of 580 is an irrational number. Okay, to do this problem here, we'll call it B. Tell you what, why don't you pause the video and see if you can do it yourself. All right, if you've unpaused the video, I'm assuming you've already tried on your own. Please don't let it just play. Do your best. And I'm going to draw a ray from the right angle to identify C. Looks like C is 25, so I'm going to do 25 squared. All right, we're going to have x squared plus 24 squared. I'm going to square everything, so I'll get x squared. X times x is x squared. Okay, 576, I think. 24 squared, I think, is 576. Let me just confirm that. Yes, I am correct. And then 25 will be 625. Now I have a two-step equation to solve. Listening to Saddam, I will take away 576 from both sides. Okay, I'll get x squared. Now, just thinking, if this was 575, I would be 50 cents away. I bet you it's going to be 49 for my answer. Yeah, I'll bet you. Yeah, 49. Now, if I take the square root of each side, hold on a second here. All right, taking the square root of each side, what times itself is 49? Well, that would be 7. Okay, now 49 has two square roots, a positive and negative, but since I'm talking the length of the side of a triangle, I don't care about the negative side. So 7 is my answer. Notice I didn't use that wavy equal sign because I got an exact answer. This is a rational number. A rational number. Okay. All right, now coming down here, we're going to combine some like terms. All right, I've got the quantity of 5x minus 4 plus the quantity of 6x plus 8. Well, when I do that, I've got a 5x and I've got a 6x. All right, I have a -4 and a +8. You know, I really should have checked to distribute first, but there was nothing to distribute. So I'm going to combine my x's and get 11x. And then a -4 and a +8 is a +4. There you go. Now in this problem here, I have a negative out front of the one quantity. Right? You see that negative? I need to distribute him. If I want to think about him as a -1, I can certainly do that. I'm going to have to distribute this -1 to all three terms. The negative in front of the quantity changes everything inside the quantity. So my new problem becomes 3x minus 2y plus 1. Those parentheses are now unnecessary, and I'm going to distribute. I'm going to get a -8x plus 6y plus 7. Now some of you would have preferred me to write it like this. So I will, 3x minus 2y plus 1, and then minus 8x plus 6y plus 7. When I do that, I'm going to combine like terms, and I'm going to get a -5x plus 4y plus 8. And there you go. Okay, some equation solving. Well, I know this kind of problem gives a lot of you trouble. Well, you don't like that there are x's on both sides, so I'm going to simply take one of those x terms away. Take away means to subtract. So the new equation, or the altered equation, becomes this. And now it's just a simple two-step equation. I'll add 7 to both sides. I'll get 3x equals 12. Divide by 3, and x will equal 4. Okay, on the second problem here, I'm going to distribute the 3. And of course, I'm going to distribute the 5 over on the other side. Okay, when I do that, I'll get 6x minus 21 equals -35 plus 5x. Looks like the last problem. I don't like the fact that there are x's on both sides, so I'm going to take one of the x's away. I've just been trained to take the smaller of the two x's away. It's not wrong to take the larger of the two away. It just tends to make things a little bit easier, in my opinion. All right, I'm going to add 21 to both sides. When I do that, I'm going to get x equal to -14. All right, so there we go. That's solving equations. Some little review. All right, multiplying and dividing fractions. Remember, I like to think of Wonder Woman. I'm going to look to simplify this way, and diagonally. I'll do the one I see most obvious. That seems most obvious to me. 20 and 30 seem to simplify first. It just jumps out at me. I'm going to divide them both by 10. That'll turn into a 2. That'll turn into a 3. Now, diagonally here, I see something. I see a 7 going into both of those. So I will divide them both by 7, and I'll get a 3 and then a 2. I don't cancel across horizontally because it doesn't follow my Wonder Woman pattern. So, my new problem, which is really just a simplified form of the problem, is 2/3 times 2/3. Nothing will simplify that way. Nothing will simplify that way. So I'm ready to multiply thanks to Wonder Woman. So I get 4 times 9. There we go. Excuse me, 4 divided by 9. 4/9 is the answer to 20 21st times 14 30ths. Ends up being 4/9. Now, before I do this problem here, I have to change it. 18 divided by 35 times, and I use the reciprocal. All right, so let's see. I got to use my Wonder Woman skills. I know that 5 is going to go into here 3 times, and 5 is going to go into here 7 times. This way, vertically down, I know that 3 is going to go into 3 once, and is going to go into there 9. So right now I'm looking at the problem 18 over 7 times 1 over 9. And then I'm going to look diagonally to the left and see that 9 goes into 9 once, goes into 18 twice, and nothing simplifies vertically on the left. So now I'm ready to multiply. 2 times 1 is 2. 7 times 1 is 7. The answer is 2/7. And boy, do I feel smart. Thanks to Wonder Woman. Anyway, I just like saying that. Can you tell? All right. So please remember that x times x is x squared, right? Okay. How about, let's see, 3x times 4y. Well, that is 12xy, right? I can multiply the 4 and the 3, and then the xy is there as a multiplication problem. Okay, remember how to do these things. If you need help with it, come in and see me. Remember that combining like terms applies to addition and subtraction, not to multiplication. Multiplication, division, is all about grouping. All right, I think that's it for this video. I just wanted to put it together, make sure you're having a chance to be successful, not forgetting the things that we've done. Mr. Lawrence signing off. Have a good night, everybody.